Alright, this video is about systems of inequalities. So a system meaning more than one, and we're going to look at inequalities. So this is less than, greater than, less than, equal to, greater than, equal to. And with inequalities, we have a lot of answers, and so we want to be able to show how we kind of gather up all of those solutions and how we would show that to whoever's reading our answer. Let's look at some examples. So the only way that we can really look at finding a solution to a system of inequalities is to graph it. So we want to graph the solution for the following linear inequality system. So we are going to have y is less than 2x, and then we have 2x plus y is less than negative 5. So these are lines first and foremost, and so we can graph them however you graph a line. So that means we can make a table of values. We can graph using slope-intercept form. We can graph using x and y intercepts. However you want to graph is up to you. There are a lot of different ways to get there. I like to graph using the slope-intercept form, but remember, if you don't remember all of those different shortcuts for graphing, a table of values will graph anything. All right, so the first one is fine. This one's already has the y by itself, so this one is good. But the second one we need to change and solve for y. So we have to move the 2x over to the other side, so we're subtracting the 2x. So on the second one, we are going to have y is less than negative 2x minus 5. Okay, so now it's good. So we're going to graph these. Remember that if they are less than and greater than, it is a dotted line. If it is less than, equal to, or greater than, equal to, it is a solid line. So let's graph the first one. Y is less than 2x. So we first treat it like a line and graph it. So in this case, there's no y-intercept, so we start at 0. And then the slope is 2, so that means we go up 2 and over 1. And then, like I said, this one doesn't have an equal sign with it, so it is a dotted line. And then we'll have to determine which side is indeed shaded. So we pick a point that's not on the line to put into there and see if it works. My go-to number is 0, 0 when we can use it. In this case, we can't use it because the line goes through it. And so we have to pick a different number. So maybe we pick 2 and negative 1. So if we pick the point 2, negative 1, we're going to plug it in. So we have negative 1 is less than 2 times 2. Negative 1 is less than 4. Is that a true statement? The answer is yes. And the point 2, negative 1 is on this side. So we shade this side of that line. All right, now we have to graph the other one on the same graph. So let's take a look. We start at negative 5. 1, 2, 3, 4, 5. And our slope is negative 2. So that means we go down 2 and over 1. And again, this one is a dotted line. There's our line, and we need to pick a point that's not on the line to see which side we shade. So this one I can pick 0, 0. So if I pick the point 0, 0, I'm going to plug that in. 0 is less than negative 2 times 0 minus 5. 0 is less than 0 minus 5. Is 0 less than negative 5? The answer is no. And so 0, 0 is over here, and so we are going to shade the opposite. So this is what's shaded. So how do I know what is the solution to the system? It's where the shadings overlap. So where the shadings overlap are really this here in this dotted area and then all in here. So we don't necessarily have to do both shadings on the graph. We could kind of keep track and just shade what they share, where they overlap. Last example, we're going to graph again because that's the best way to show inequality solutions. So we have y is greater than or equal to 0. We have y is less than x, and we have x plus y is less than 6. So we have 3 of them. Doesn't matter. We graph all the same way. So let's get our Cartesian coordinate plane up here. So as you can see, systems can be of all sizes. It could actually be thousands of inequalities. It just depends on what we need them for. Okay, so let's look at the first one. Y is greater than or equal to 0. So for y is 0, we're right here on the line. It is greater than or equal to, so it's a solid line. And then greater than, so these ones are a little bit easier. If we think which way is bigger on the y, it's up, so we would shade up, going up. So just like this. Okay. I'm going to take that off because let's just keep that in mind when we go to shade it, because I want to just show you the entire where the solution is. Y is less than x. Okay, so notice this is really a plus 0 here. So we start on the 0, and then there's really a 1 there. So we're going to go up 1 over 1. There's no equal sign here, so it is a dotted line. Okay, and we have to pick a point that's not on the line in order to test to see which side to shade. So let's pick the point to -1. All right, -1 is less than 2. Is that true? It is true. So that point is over here on this side. So then we would shade this side. So now we have to keep track where are they overlapping. So above the blue line, below the red line. All right, and now the last inequality. So the last inequality, I'm going to get it to y equals, or y is less than, y is all by itself, negative x plus 6. So we're going to start on the 6 on the y for our y-intercept, and then there's a 1 in front of it, so we're going to go down 1 over 1. And this one is going to be a dotted line because there's no equals with the inequality. And then we have to determine which side to shade. So I'm going to pick 0, 0. So we have 0 is less than negative 0 plus 6. 0 is less than 0 plus 6. 0 is less than 6. That is a true statement. So we're going to shade going down this way. So if we keep track of where all the shadings overlap, they overlap in this little triangle. So what really is the solution to the system is all in here. That's it. That's it for this video. As you work through the lesson, if you have any questions, be sure to ask your teacher. Have a great day.